All right. Well, we actually have something special for you. We have something that otherwise you might think to be physically impossible. We have a talking asshole that's going to be presenting the next talk. Hey, he said I could say that. Actually, it's Justin Ferguson that's going to be up here talking about bridging the gaps. Let's give a big round of applause for Justin.
Thank you. A lot of these types of talks tend to be, you know, here's how to use this tool under, you know, for doing this and so on and so forth. And this isn't really, excuse me. A lot of these types of talks tend to be more focused on using tools that already exist, and this isn't really one of those talks. However, about 5 months ago, I made the mistake of, well, 4 or 5 months ago, I made the mistake of talking at a conference, and my entire presentation was all assembly, and 90% of the people in the room didn't have any idea what I was talking about, and I was putting myself to sleep. So I tried to find a happy medium here, and I'm thinking after what I've been seeing this weekend that it may be a little high level, but if that's the case, the code should speak for itself, so I apologize in advance. Basically what I'm going to talk about here is, you know, I wanted to try real hard not to talk just about the PE format. It's a very, to me, when I looked at it, this was the hardest part of writing. This was basically all I'm doing is going through and parsing the format and printing it out, and then I'm doing, you know, other things too, but it's hard to really talk about that without just talking about what the format is and kind of just reading the structures to you. So I'm going to talk a little bit about that, but more how it applies. I'm doing what specific members of structures are interesting, so on and so forth. Again, I'm not going in depth into it, so some understanding is expected, and that's that. So the reason, well, backing up, what I did is I wrote a tool kind of like object dump for PE executables. Specifically, it works under Linux, it works under BSD. In theory, it should work under just about anything that's POSIX compliant. Haven't tested all of it. My reasoning for doing that is sometimes I don't like booting up VMware. I don't want to reboot into Windows. I don't want to do all of that. By default, I'm sitting behind a Linux box all the time. So it's quicker when I'm just trying to look at something and do a 10-minute check of what's actually there. You know, if I can just look at the imports and exports and so on and so forth, I can get an idea of what the program actually does without ever having to take too much of a look into it. Kind of a less not as strong as a point is for people getting into it, you don't have to worry about accidentally double-clicking on something you shouldn't have and wiping a box. And then also, you know, why not? I mean, I felt like doing it, and that's the main reason why I did. As I'm sure pretty much everybody knows, executables come in, you know, predefined format almost all the time, the exception being boot records and things of that nature where it's just a raw binary. Most of them, you know, define information like the text segment, data segment, things for the linker in the system, and so on and so forth. We have a lot of different popular ones, ELF, which you'll probably be using under Linux, BSD, etc. COF, which is the older Unix equivalent. A.out, which is another more, it's what Linux went to or was at, and OpenBSD was a long time. Prior to finally going over to ELF, and then of course PE, which is what Windows is using, which is, again, it's an offshoot of COF. If you try to use object dump on a PE executable, it has some understanding of it, and that's because it understands COF format. And I guess the background is that when Microsoft went in and actually started making a format, they hired a bunch of guys from the older Unix crowd. The only thing I'm going to talk about and cover here, and this is all the tool really deals with at the moment, is images, not objects. I'm not dealing with any of that at the moment. Eventually I'm going to kind of deal with everything, but at this present time it's kind of, it's not really there yet. So basically what's in a PF executable, or PE executable, is you have the DOS header, the COF file header, an optional header, data directories, and section directories, or section headers. And in the optional header, you have the first 8 fields, which are basically, that was what was defined in the original COF format, and Microsoft is I don't really want to say bastardize it, but basically that's what they've done, and added a bunch of their own Microsoft-specific fields. So starting off with the DOS header, there's not a whole lot that's really interesting for our purposes. It's actually a valid Win16 executable. If you run it under, 16-bit DOS, it's going to print out. Typically, the string's definable, but or user definable, but typically it's going to print out. This program cannot be run in DOS. Cannot be run in DOS mode. The only thing that's really interesting to us in the DOS header is going to be the location of the start of the PE header. But even that starts at a fixed offset, or every executable I have, the Microsoft spec isn't exactly clear on that, which one is correct. It says it's at offset 3C, and it also says it's specified in the DOS header. So typically I just use whatever's in the DOS header, or that failing and it doesn't match up, I'll go to hex 3C. PE header starts with PE, and actually my slide here is incorrect. It starts with PE00 as the magic byte. We have a few different useful fields there. The machine type, my program currently only supports i3, and it's mainly just because I wrote, and I'll talk about this in a little bit, but I wrote the tool in about 4 days of no sleep, so I was just trying to get what I could out. You got the number of sections in the section table, which is going to come up later when I start talking about the sections and such. And then the size of the optional header, which, because not everything has to be in there, it's variable length. And then we also have, a file offset to the cough symbol table. I didn't support for that, and the main reason being that I'm looking at malware most of the time, which typically has all of its symbols stripped out. So getting down to the standard cough header, we have the magic field, which is going to be 10B hex for PE32 and 20B for PE32 plus. Again, just because I wanted to stay specific, PE32 was the only thing discussed right now. From our viewpoint, the size of the text section, the size of data, size of BSS, entry point, and the text and database addresses are going to be what's interesting for our purposes. Also in the optional header, and there's going to be things of different use. Like I said, with the base addresses for text and data are both interesting to us. The entry point is going to be interesting to us. When we use the base addresses for text and data /BSS separately, it provides a good starting point for walking through all of the different file sections and so on. We still have to be careful that we don't want to trust what's in the file too much. You end up with a lot of invalid memory accesses if you start doing things like that. Together, we can actually start doing things like detecting, real basic packing, where entry point points to something that's in data or wherever, someplace outside of where you'd kind of normally expect it to be. Everything else in the optional header, it's interesting, but for what I'm doing right now, it's not really incredibly useful. We have the base address and the checksum, which, according to the spec, is not always used. I think the only real places it gets used is in special Windows system files. The number of RVAs and the sizes of the sections and such are going to be interesting to us. They're in there. And we have to walk through all the data directories to get any information out of them that we want. And that's really the big difference. The pulling out of the data directories is going to be the biggest, or pulling information out of the data directories is going to be the biggest difference between object dump and this, because it doesn't have any idea or support for any of those. All of that data gets lost. Again, there's a lot of other there, but at the moment, I'm just kind of parsing what's there, so it's not incredibly interesting to us. And I'll get into this a little bit later. I want to kind of rewrite it and do it more like a loader, in which case some of these things would be more interesting. Getting into the data directories, they exist within sections, or they can be at the start of a section or whatever, but typically they're, you can have multiple ones within any particular section. And they're very clearly, quote unquote, clearly defined. And inside of the optional header, there's a base of 16 data directory entries, but it doesn't necessarily have to be 16, just Microsoft has defined, here's 16 types that we know. Can't recall encountering one that had more than that, but they very well could exist, and I believe that the COF specification actually talks about that to some degree. And we also have the number of data directories, we should actually be checking the number of RVA and sizes, member of the optional header, to determine how many data directories are actually there when going through and parsing it. So, and getting into it, we have the 16 base data directories, which is the export table, import table, resource table, et cetera. You can see them all there. The only things I'm really dealing with at the moment are the export table, import table, address table, and I believe that's it at the moment, and that just provides real basic information about what the program actually exports, if it's a DLL, or imports otherwise, or both ways around. Getting into the section headers, we have the generic information for .text, .data, etc. It's going to immediately follow the optional header. There's no pointer in any of the headers that tells you where it's at. You have to calculate the address by yourself. And then we also have to use the number of sections to determine how many are actually there. What purpose they have to us should be fairly obvious for the most part. I mean, that's where all the data exists, and that's how it actually is segmented up. The name of it is going to be an 8-byte null-padded UTF encoded string, which if the name is exactly 8 bytes long, then it's going to get truncated, and the null is not going to be there. The size of raw data is interesting because that's the physical size of this particular section on the disk of the disk of the system, and then a pointer to it's going to be the actual physical file offset that we're looking for. And then characteristics is just going to be basic characteristics describing the section. Is this executable data? Is it initialized? So on and so forth. Everything up to this point is mostly existed at specific offsets that can be calculated. Everything else is defined within the executable itself, or it's not defined within the specification for PE-COF. To summarize, basically, we have the DOS header. It's only there for its legacy. It's only there for 16-bit mode operation. COF file header and optional header describe the image as a whole, whereas section and headers describe specific sections within it, and then the data directories are actually getting smaller inside of that. Getting onto the program itself, I ended up calling it dupe, just for dump PE. As I said, it's supposed to be like an object dump application for PE-COF. I wrote it for the conference I started off talking about 4 or 5 months ago, and just the way the circumstances broke down, I didn't end up getting released again to release it. It supports static analysis of the text segment. I go through, I can either dump only text, or I can dump anything that's marked as being executable. It'll go through and take the opcodes and turn them back into mnemonics and so on and so forth. We'll do ASCII dumps of .data, and then basically we'll read the DOS header, it'll read the PE header with the COF and or the file and optional header, so on and so forth, and display about the image data directory and the export data directory. Eventually, I want to support everything. It's just it's a very large project, not very large, but it's large enough to do all of that. And when I got down to it, I felt the way I had already started doing it was kind of wrong, where I was more parsing patterns and to some degree. I wasn't doing it like a loader, which is how I really felt that I should end up doing it. So at the moment, that's where it sets, and I'm going to start rewriting it to get it like that before I actually start adding support for the other parts of the data directories and things like that. As far as complications in parsing it, the first real handle I had is how am I going to parse those opcodes. As I said, I only wrote this in 4 days, so it should be fairly obvious that I didn't end up writing anything to parse it myself. You have 3 basic options from everything I saw. You have, libbfd, libopcode, I don't know if anybody here has ever worked with them, but it's a fairly obvious reason why I didn't choose to do that. The biggest reason I'd say is it just does not have very good documentation. The advantage, if I had used it, is I would have had integration into GDB and other tools that based off of that. libdisassemb, and I'm going to talk about, I believe in the next slide, why I ended up using that or writing my own, which is something I'd like to do, but just due to time constraints at the time, I didn't end up doing it. libdisassemb was nice. It had a very low learning curve. There's only like 3 or 4 exported functions. They're fairly well defined. The interface itself isn't ugly. If you start looking at the code, it should be really portable. It's written very cleanly. It was almost all ISO C, so it should port to almost everything. It also supported Intel and AT&T syntax. That's a big one to me. Depending on what I'm doing, I enjoy both, and a lot of the Unix tools kind of only go with AT&T, whereas most of the people working in the Windows world prefer the Intel syntax, so that was a big one. And then probably the biggest selling point to me is that it actually has this functionality where you can follow, it will display or dump data by following actual flow of execution as opposed to just, address 1, address 2, address 3, or, whatever. And you have to do that via callback, and you actually deal with things like stack manipulation or anything that touches memory and so on and so forth, but it provides the ability to do kind of quasi-dynamic analysis without actually ever running the executable, which is another reason why I think it's important for me to get it set up as a loader type interface, so I can set it up just like Windows would and then run over it like this, and be able to do a lot better of a job at what it's doing right now. Next real thing that I had as far as complication, and it's really not, I just figured it was worth putting in here, is translating RVAs to physical file offsets. Wasn't incredibly hard, but they're offsets from the beginning of the file. So for any given RVA, which for anybody that doesn't know, an RVA is a relative virtual address, which is basically an offset without the base address in there. So we just take the memory mapped base of the file that we're looking at and add the RVA to it. Finding data directories was a lot more, finding or dealing with the import data directory was a lot more complicated, but another hurdle we run into with data directories themselves is that they don't necessarily start at the start of sections, and there's no direct pointer, there's no direct file offset to finding it. It was still fairly easy to find. You basically just had to go through and start looking at it and say, does this address fall within this range of addresses, or does it start at this address? If so, then we've got the section, we use the file offset, and then we know it's within there. And then if it falls inside, what we're going to do is subtract the RVA of the data directory, the section RVA from the data directory RVA, and it's going to reveal the file offset, and then we'll just add that to the mapped memory base address, and that'll give us the start of the data directory. If it's at the start of a section, then it's real easy. All we do is use the pointer to the raw data, or pointer to the raw data, and start going from there. Data directory gets a little more interesting. The Microsoft spec in the implementation of things that I saw were kind of 2 different worlds in a lot of places. What's in the data directory is going to be the list of all of the imported functions, whether it be by name or whether it be by ordinal. This is going to be one of the where I'm sitting down for 10 minutes to take a look at a program that someone found that they want me to take a look at. This is typically what I look at for the most part. What functions does it use? If the program starts opening, it does an open process and locates memory in the other process and spits text into it, then I pretty much know that it's doing something that it may or may not supposed to be doing, but it's a good indication of it. And then the specification says the import data directory is null terminated, and that's not entirely true. What I found, kind of skipping ahead of myself, but what I found was that I actually had to check the entire structures, not just for a null pointer. If I just did that, then I was running into things where it actually was, there was still data past that, so I had to do like a mem compare. And again, the IAT, the import address table, is supposed to be null terminated, and it's going to be a... Okay, and you're supposed to have the IAT and the ILT. It's supposed to be the same thing until the image is bound, which again, I found was not always the case. Microsoft does some optimization. Borland does their own little thing. And what's in the specification isn't necessarily what's in the binary. And then when we actually get down in there, the integer is a bit field. If the most is set, then the function is imported by ordinal, and all we're going to be able to print out is the ordinal number, obviously. Otherwise, we can use the RVA there to actually find the name of the function. Or find the name of or find the RVA to the hint name table, rather, and inside of that, we can actually find the name of the function. There's going to be a variable length null terminate ASCII string that actually tells us what is being imported. There's only one of these, so we can actually just walk through the whole thing if we wanted to. Anyways, getting back to the problem, as I said, it's not necessarily null terminated like the specification says, but I have to test to make sure the entire structure is empty. Then also, even though the specification says that it's supposed to be both the IAT and the ILT are supposed to be the same thing, they're not necessarily the same thing. Some Microsoft are exactly what the circumstances are under Microsoft compilers, but it'll actually optimize it and stick a lot of this data in the text segment. And then Borland will actually take the ILT and initialize it to 0, and the IAT will contain the RVA. So we actually have to check both and deal with these circumstances. Otherwise, we end up with incorrect data. So if we want to find the name of an imported function, what we end up having to do is determine the address of the import data or import by going through and finding the data directory, which is it between these two addresses, and so on and so forth. As we loop through that, if we find that the whole structure is 0, then we need to exit out because we've gotten to the end. And then if we're not at a 0, or if the entire structure is not 0, then we can proceed walking down it until we find the hint name table. If it's not 0, excuse me, once we determine that the entire structure is not 0, we need to check the import lookup table and 0. And if it is, then we actually need to check the IAT, and that's where I believe it was the Borland compilers that were doing that. So getting into the future of what I'd actually like to do with this, like I said, I want to make it act more like a loader. It is, right now I'm decoding the structures, or parsing the structures and so on and so forth like I would, but I'm doing it from one mapped memory address, or I'm mapping it in once and not really doing the entire thing. I want to everything that's in there and have full capabilities as opposed to just limited, here's what I'm looking at, here's a small section of it, so on and so forth. The libdisassembly functionality that allows dynamic analysis to me is the biggest selling point. There's nothing, I've never seen anything that's really doing that without actually executing it. So to be able to do that actually gives us a lot of different functionality. And then I'd like to give it a better interface, just because I don't like the 80 by 60 displays, and then trying to actually format it and figure out what you have without using something like that is a little bit problematic. As far as what we could build off of this is just off of, instead of just object dump itself, there's a lot of stuff you could do with antivirus, especially when you start doing the pseudo dynamic analysis. Once you start getting that in, you can start doing things like packing it, or unpacking it, and then you can actually do heuristics off of that. And there's a huge gap in this right now. ClamAV is not very good. I can't think of any real Linux-based open source mail server or antivirus for mail servers that I'd say is really up to par. And to be able to do this, we could actually probably improve things a lot. And even though no one's really using, no one's dot slashing whatever .exe on their Linux box, not only because it doesn't work, but there's no use for that. But where the antivirus does come into play is on mail servers and things like that. It would be interesting, to have native 32-bit Windows binary support in Linux and so on and so forth. It is a lot more complex though, and we also have to port over the user land, but then we also have the problems with, there's a lot of things like the process versus thread model of how things are actually done. Unix has no real support or no idea of opening another process and injecting code or locating memory, so on and so forth, whereas Windows does have that idea. So that would actually need to be something that would need to be emulated or would actually need to be applied at the kernel level in addition to that. So you're kind of breaking things, kind of breaking the whole segmentation model of processes and such. Do you have any questions? Actually, I think I'm running really early. Oh. So the last presentation I gave, I ended up having to go 2 hours when I was scheduled for 1, and because I had too many slides, and at this one it appears that I have too few slides. So it looks like we're probably going to get done a little bit early, but if anybody has any questions, all 10 of you, Excuse me? Okay, well, I'm going to go ahead and guess that no one does. I appreciate it. I apologize for my monotone voice, though.
Pretty short talk. What's that? Yeah. There's one more talk in here, right? Stuff in the back. Oh, yeah, the closing remarks.